in this problem, we're gonna try to find an inverse function of some function f that's given by the square root of x plus 1, and it's defined on this interval 0 plus infinity and going into some interval b that we have to determine. So the first thing that we need to do is that we need to find b so that f is surjective. Okay? And after that, we have to make sure that we get the function, the inverse function of f. Okay? Without worrying about b, we can graph this function here. So this is basically, so this is y equals x. So square root of x plus 1 is just a shifting of the square root, the square root function. It's gonna be something like this. Okay? So it's just a shifting. Okay? So that's we see that the range is 1 plus infinity from the graph, but we need to prove it. Okay? So we know that f is f is defined on 0 plus infinity. That means x is bigger than 0. Okay? So when we take the square root of x, it's bigger than square root of 0, which is 0, and we add 1 to both sides, we get square root of x plus 1 is bigger than 1, which is y. So that means y is in this interval y plus infinity. And this is our b here. Okay? So this is the whole interval. And in fact, any points here has a preimage. Okay? So that means f is surjective by construction now, by this interval. So we can also say, or from the graph, that the image f of this interval is the whole set b, which is 1 plus infinity. Therefore, f is surjective. The next thing that we need to prove is that we need to prove that f is injective. So let's have two elements. Let a be in this interval 0 plus infinity. We assume that they have the same image. What we need to prove is that we need to prove that they are the same. Okay? Okay, so but from here we know that f of a is equal to f of b, means that the square root of a plus 1 is equal to square root of b plus 1. So that means square root of a is equal to square root of b by subtracting minus 1 from both sides. So here, since a and b are in this interval, so when we square both sides, we just get a equals b. And this proves that f is injective. So f is both surjective and injective. Therefore, f a bijection. So therefore, f is a bijective function. Okay? And therefore, f inverse exists. Okay? So f inverse is gonna be, from this interval 1 plus infinity unto this one 0 plus infinity. Okay? For some y, it's gonna give us x. Okay? But let's do the traditional way. Okay? So in our case here, we have f inverse of y is x. That means f of x is just y. Okay? So we can solve here. So we have the square root of x plus 1 is y. So we take 1 to both sides, we get square root of x is y minus 1. Squaring both sides, we get x is just y minus 1 squared. Okay? And this tells us that if we let y, we switch y and x, we get y is x minus 1 squared. And this means that our inverse function is that given by this one here, x minus 1 squared. Okay, we can also proceed from here. So from here we can, but we are looking for the F inverse. We don't know the F inverse. So it's better to switch to this one here, because we are looking for an expression of this one. But we have an expression for F. That's why we solve and we switch back. Okay? Anyways, the X and Y are just dummy variables. So the most important thing is this domain here. Okay? So this shows that our inverse function is given by x minus 1 squared. To make sure that we got the right thing, we need to check that f of inverse of x is just x. And once we do that, we get this result. That means the f inverse of x is just x minus 1 squared. Okay? Thank you.